Good. Okay, well, just in case it's just the four of us, if we just start, I just wanted to bring up a few topics that I thought are useful, and of course, you guys let me know if there are more topics that we should be talking about. But I wanted specifically today to talk about some issues we're having with connectivity, and this is a sort of firmware issue which I've been investigating. So connectivity, also the sort of transition away from Watson. There's lots of implications there, and I sort of want to make a decision about that today. And I think, Václav, you had something to talking about processing, right? And how you wanted to process OpenEEW?
Yeah, like data ingestion and saving.
Okay. Yeah. Okay, so you got some news there. And also what I wanted to talk a little bit about was historic sort of sensor data, because I wanted to debug what's happening in, so that I'm going to put that into the first topic. I want to debug what's happening with sensors that we have at the moment. So if I can just start, if you guys don't mind, I'm just going to say, so right now what's happening in Puerto Rico is our sensors are not stable. Like there's something going on. So like a couple of people have told me there that the sensor that they're now hosting turns off suddenly. So they have to go and reset it. And so they're all using the dashboard a lot to check the sensors, and they're resetting. Now this is really strange to me because this is not something that I've experienced before with Grillo sensors. This is a new phenomena. And I'm not sure exactly what the answer is, but I think we need to have more data to really understand this. And one thing that's really missing is a history of connectivity, which is something that we've done in Mexico, which is the idea that you not only know how long if something's on or off, you know how long it's been off for, how frequently it goes off. So you can tell the quality of its connectivity more than just its status at any one moment. So what I'm going to start doing is I'm going to start saving data from, I'm going to start saving data from the network and just starting to plot it out somewhere, just until we get a sort of fancier solution. I don't know whether ultimately, even in the dashboard one day, we could have that feature where we could see a histogram for a specific sensor. But I feel like that's a really important bit of data that we're not able to see at a glance.
That's actually, and if I may, that's actually something that I started doing a few, well, not a few days back, yesterday actually. I subscribed to Watson, and I subscribed to also the Mexican MQTT and stuff, and I started converting to the mini-seed seismological format mini-seed and archiving all the data, so we have an idea about how much downtime there's for sensors. And I'm not really sure how much we, as the group that is today present, we have insights into that. But it sort of concerns me a little bit, because I was trying to get some data from some of those Puerto Rico stations, and although they were green in that Node-RED dashboard of John's, they were not really responding and sending data.
Because they must be on the STALTA trigger, right?
Well, but there should be it should be possible to send a history. Well, it should be possible to switch them to continuous data, or send a history of 10 seconds, or send a whatever number of seconds you type in. So they should be responding on the call. And I didn't try all of them, but I tried a few, and I got a response from one or two. I got data from one or two that were working on trigger mode. But I didn't really get data from the other ones, and it's sort of, I don't really know what's happening with them then, because they were.
Well, the simple solution is just to turn off the trigger mode. I don't think Elizabeth just joined us. Hi, Elizabeth. I don't think we need the trigger mode for the Puerto Rico network. So
for sure not. But I was trying to turn off on trigger mode and switch them to continuous mode, and I didn't get any data anyways. So it may be something with the Node-RED dashboard, but it may also, I don't really know. That would be nice probably to discuss with John. I need to message him because it seems to me if I am subscribed to the data, and obviously I think that I'm that's all right, because any sensor that I turn on at home that works well, and also I got some data from Puerto Rico, so I think that the endpoint is correct, and this subscribing to that should be all right too. So I don't know what's going on. I don't think that there's some sensors are just not sending data. So
it could be a firmware bug. I think the firmware's become quite large, and I wonder whether there might be some condition which we hadn't predicted, which we're seeing now, where it just gets stuck in a loop and it doesn't send, some error situation. And I can imagine that happening because I've been experimenting with GPS here, and I've seen a few conditions that I hadn't thought of before. So, which is when GPS goes, it's not sending stuff. So I suspect that there might be some Wi-Fi situation, or even some MQT situation, which is somehow, just causing everything to get stuck. So I think we need to go through the firmware again, line by line, and just see where that might be happening.
Yeah. Hopefully it's something easy, but we definitely need to get to the bottom of it, because how many sensors should be online right now in Puerto Rico? Do you know?
Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And what's actually happened is this problem, actually not this problem, a related problem with Node-RED has caused the guys in Walmart to slow down, because it was becoming a bit of a pain for authenticating. And I suspect that's a Node-RED problem or a firmware problem. So Node-RED might be causing some issues there.
Yeah.
Sensors not sending data. I'm just taking notes.
How does error handling on the? I mean, can you get logs from each one of these sensors? Like, what is the output of these sensors as far as if something goes wrong? Can you see what is going wrong with it, or do you have to communication with the actual sensor?
Yeah, so we don't have that. We do in Mexico. We don't have that in these sensors. So in AWS, we had a sort of a logging message that would work. I think what's happening here is that that it just sends the waveform data, and anything else we can request it via MQTT. And when it disconnects, at the moment, Watson has some built-in MQTT function to know it's disconnected, which is a last full and testament function of MQTT. I don't, and that's just any MQTT server does that. So that's all we have. We don't have more information about the error. What we could be doing in the firmware is sending a message when something goes wrong, if we can understand what those conditions might be. So we could be, printing out something and sending it. But I don't know whether the problem itself is the MQTT connection, for example, and then we're not going to be sending any messages because we can't really store things on the device.
Right.
So I think the way to debug this is to just have, I think the initial way is just to have a history of connectivity. So because then we can start to learn about situations, are they all disconnecting at the same minute of the same day? That would be interesting. Yeah. Are they all disconnecting for an equal period of time every time they disconnect?
Yeah.
Sorry, Elizabeth, go ahead.
Yeah,
Sorry.
I was going to say that record of connectivity would be critical, because I'm not sure how much the instruments depend on things like power or internet connectivity, all of which on the island may not be completely reliable.
Mm-hmm.
So if we can line up and say, okay, this station went down, and link it back to a power problem or an internet outage, then we know it's not the instrument, but rather other issues.
I think that hopefully in a few days, I will have a better idea about the reliability of the firmware and the connection, because I just set up 18 or so instruments at a single board, and I will run them all at the same time. So if any errors happen in the firmware, I should be, or hardware, I should be able, hopefully.
My concern, though, so I think that's very handy, but my concern is that there could be other conditions you can't predict. So there could be different types of routers. There could be some interference in Wi-Fi potentially. It'd be good if maybe half of those, the ones you tested with Ethernet, and half you tested with, I don't know if you have enough ports in your switch, but it'd be good to test both. But yeah, I agree. We need to have that history. So we can tell, we can make an intelligent guess about this.
How, Václav, are you getting the history, or how? I guess we don't. So we don't even have, because I'd like to include that in the dashboard eventually, because I think the dashboard, I mean, for the most part, we should be expanding the parts of the dashboard that allow managers of these sensors to be able to get feedback from the sensors, right? Because really now all you can see is just like two colors on a map. The colors don't even really respond to whether or not it's actually online or not. And then you can send some messages to the sensor. But like there should be a lot more sort of debugging abilities on that page for the sensors. So a history of connectivity, I think, would definitely be good for the dashboard. But I figured that would have to rely on more than just a timestamp in the database. Right? So how would we?
Let me explain that part. So Elizabeth, by the way, would be a perfect network. She would probably, I'm assuming Elizabeth would want to know of the status of devices all the time if as a network manager.
Yes, absolutely.
So I suspect she would agree with that assessment, Brian.
Yeah, and Elizabeth, I mean, you're you're the type of person that I'd love to talk to, and if you have any ideas about exactly like how we could expand that sensors page or what you would like to see in it, I mean, the feedback from people that are actually using this page is really invaluable at this point.
Yeah, and I guess one thing from like the network seismologist point of view is if it can be integrated into things that we are already and our analysts are already familiar with, things like SeisNet Watch, kind of like the Quack system. I guess that's by Paul Bodine at Pacific Northwest. But there's also tools on Iris that are open source that a lot of the networks use. And if we can integrate kind of the same type of quality analysis without having to have a new tool and have an analyst go, you've looked at these stations, now you have to go and analyze these other stations in this other tool.
Yeah.
So Elizabeth, in a moment, I think Václav might help with that question because he's been looking at how to get the data into sort of more standardized way for seismology. But I just want to one other point very quickly was Ryan. So for you to draw that histogram. There's a really straightforward way to do it, and it all comes down to getting out of Watson, which we're going to do anyway, obviously, because we can't have Watson for much longer. And so every MQTT server has this thing called last will and testament, which basically means that the server is remembering, the MQTT server is remembering when a device is connected or disconnected. And that becomes available through I think it's a topic that you could just query. So in AWS you use a Lambda to get that information. In any other MQTT server you just however you do it. And so then that just you just plot those out. So you just plot this out. That message will give you the time and will give you the disconnect or connect status.
Oh, okay.
And over time you just plot those messages.
Oh, okay. I mean, that's simple enough to do. Yeah, I mean, I would definitely like to add that. So what is the, and I guess this goes to a different part of the conversation, but so what is the status with VernMQ at this point? Like, are we, we're definitely doing VernMQ, right?
Yeah. So we need to look at this, but we definitely are not doing Watson because it's really expensive. Mm-hmm. So we have two options, Vern. But there's an option maybe to use AWS. And the reason I mention that is because AWS has given us now credits for the Caribbean project almost indefinitely. And so I don't see anything else which is going to secure the longevity of this project as well as that. So I've already got a version of the firmware which sends to AWS. And it's a couple of lines change. So I'm going to suggest we use that as a potential way to do this, that we ingest all the sensors through AWS IoT. It's something we're very familiar with. We already have lots of things set up. And actually, there's a few other AWS services we should be thinking about because we need to get the data into AWS Open Data anyway, which is how researchers use our data. So it makes sense to have at least a fire hose going out from AWS IoT and just storing it periodically, as we already do in Mexico, into into an S3 bucket so that people can use it.
Yeah.
So that's one option. And I would suggest that maybe that might be better than Vern, because Vern relies on IBM Cloud again, which has a sort of time limit to it for us.
Okay. Oh, and whatever we use, though, that will and testament will be that'll be available, right? And it all sort of works. That's sort of an MQTT thing rather than
it's a complete
platform thing.
it's a standard thing in all MQTT brokers. I'm sure it's available in Watson, but Watson seems to be a non-standard one from what I can see. But it's available in AWS and in Vern and in Mosquito and in any other one. So that was all I had to say really before we go onto UVASLab. But I am sort of quite keen that we start exploring the connectivity issue and the swapping the MQTT server as soon as possible. And I just want to make a final point there. The authentication system seems to be failing a lot at the moment. And I have so whilst OpenEEW should continue down that path, I'm wondering whether for Puerto Rico it might be better just to somehow go around the authentication system. Because we know exactly which device is going where, so we don't need users necessarily to, tell me if I'm missing something here, Ryan. But we don't necessarily need a user to provision a device through an app. We just need them to connect to the network, as long as we know which device is which.
But when you say authentication, do you mean the provisioning process to add a new sensor, or the authentication?
The provisioning. Walmart have stopped adding sensors because the app doesn't work for them. They can connect it to Wi-Fi, they can't do anything else. And honestly, this is a problem we've never had before, because in Mexico and Chile, we just used to put sensors down and just used to say sensor 562 is in this part of Puerto Rico. I didn't see why we can't go back to that system now. So at least I'm just talking about Puerto Rico implementation. I'm not saying that this needs to change OpenEEW, but at least in Puerto Rico, I'm seeing this is causing some delays now.
I mean, I've always been a fan of just adding a manual way, whether it's the primary way of doing it or a backup, just adding a way to add a sensor from the dashboard, right? I mean, it would just be a simple form on the dashboard that sensor would be automatically tied to whatever account you are currently logged in on. Because from what I realize is that we don't really have to take, seismologists, from my understanding, are very used to just adding the longitude and latitude of where exactly the sensor is located. And beyond that, there's nothing else. There's no other specific information that you need a computer to tell you, really. Mm-hmm. Except for, I guess, the MAC address. But that also presents another question of should we be labeling these sensors by MAC addresses, or should we be labeling them in something that's a little more seismologist friendly, basically, which is to say that it's, a label that would allow you to know what sensor you're referring to in the data rather than looking at some MAC address, which means nothing.
I think that makes sense. Yeah. So what would happen is that when we create devices, or when we flash them, this is what we've always done before Puerto Rico, we just assign a label to it. I'm sure Elizabeth might have some ideas about what a label should contain. And then that, but it could be anything. It couldn't be just a number, which we then add metadata to. And then that label is forevermore associated with that location.
I think also it may be just a variable in the firmware network and station, which can be changed potentially also through some kind of a command line or dashboard. So like in seismology, that's the common way of distinguishing stations. It's a network code and a station code, and then those channels on the stations and stuff like, or locations on the station. But I think that it can be, I can imagine that being a variable that can be changed even remotely. So we don't have to do it when we flash the device necessarily. It does not need to be given to the station forever.
Yeah.
Yeah, and I guess one thing with naming conventions is that if something is co-located with a station that already has a name, that station has to have the same name.
Oh, okay. Oh, like the exact same name, or some sort of like...
And that's what it would be, is a network code and then a site name.
Network codes. Okay.
And then possibly location code, which is 2 numbers like 0010, and then your 3-letter code that tells you what component and the channel type.
And as far as a network code, would all of Puerto Rico be on the same network, or do you have like individual networks within Puerto Rico?
Well, the main network is the PR network, which would be PRSN and Puerto Rico Strong Motion Program. But we do have an IU station on island, which is a global network.
Okay.
But the question comes down to, is this network going to be distinct enough that it needs a different network code recognized by the FDSN?
Okay. And then if we did do that, let me just ask this quickly. Like if we did do that, Andy, are we getting from the provisioning app some sort of connection to the MQTT broker? I'm sort of
no. So the device is out of the box. Oh, hang on. Yeah, we might do, but we can hard code it. So
yeah,
so
we have to figure out that.
I'm trying to work out the difference between Puerto Rico and OpenEEW in general, right? But what I'm thinking is just to simplify this, just to get rid of this problem that we're having, we hard code the endpoint and we hard code the device ID into each individual bit of firmware. It's not a big deal, you know. I mean, it's 100 devices; it doesn't take long. And then what happens is we bypass that whole authentication stuff.
But I think that the endpoint can be changed by the dashboard, right? Like right now, that there is that Node.js flow that changes the endpoint.
Mm-hmm.
So I don't think that one necessarily needs to be hard-coded. There is the MAC address that acts as a unique identifier of the station and probably is a good way of identifying the station by the computer. But we also want to have some kind of human-readable or following seismological convention naming, which is network code, station code, location code. So, and those can be assigned through a dashboard, just changing variables in the firmware. But like it can be assigned by like communicating with like MQTT or over MQTT with the sensor. So I don't think that it would necessarily mean anything else. Like we would need to change the firmware a little bit to accommodate these variables, but otherwise, I don't think that there would be anything different.
Yeah, so we potentially could keep with the MAC address as sort of the primary ID, but then allow for, and we've discussed this before, but allow a separate like network identifier that you could change yourself from the dashboard.
That's what I would suggest.
Oh, I see. Oh, that's good.
That seems
because then you can change it. You can make it anything you want. It doesn't change the primary key in the database, basically.
Exactly. Yeah. So the MQTT message is still defined by the MAC address, or it's going to be like one entry in there.
So all I wanted to do was reduce, because of these problems we've been having, I just wanted to reduce the amount of work that's going through Node-RED, because I suspect that that's where some of the issues might be happening, and have it so as you say, that makes sense. The MAC address is already a fixed entity, so we just send the MAC address and then we append that information you're saying later on in the dashboard in terms of the network. Is that right?
Well, yeah, so that's how I understood it. But if we want to add, so I'm trying to think of how we might add a manual, like add this sensor on the dashboard. And for that, then for this to make sense, then we would need to know, that person would need to know the MAC address to be able to enter it in that.
I understand what you're saying. Yeah. Okay. Well, that's
So
pretty
is that
straightforward. Yeah,
Yeah.
that's pretty straightforward. So at least it's very easy in Puerto Rico, because every sensor that goes to Puerto Rico passes through my hands, for example, you know, and I can read the MAC addresses off and print them and stick them on the box. So that's pretty straightforward. The ones that are already there, we can get the MAC addresses from each one very easily. We can see on a map which is the MAC address of each location.
Okay.
So I think that should be quite straightforward.
But that's exactly, Ryan, that's exactly what I think. I think that you are right. Like you can add the first time when you plug in a sensor, you add it dashboard to the dashboard by typing in the MAC address, and then you can interact with the sensor. Like we have all these different interactions, and I would probably suggest a slight change to them that they would include changing the network code, station code, all those other things that we just talked about, and that would be same as other interactions with the sensor as we have it right now. It just would be a few more variables in the firmware. Okay. But otherwise, just typing in the MAC address for the first time, adding into to the dashboard, and yeah, and I think that's.
But Vasav, I'm not sure there are more variables in the firmware. The firmware just sends the MAC address, but those things get appended and saved on the database. They don't get saved in the firmware. Those are not variables anymore. The firmware just issues one single identifier, which is its MAC address, and then we add all. Yeah, sorry.
That's a good point. That the station may not even need to know.
The station doesn't know. That stuff gets added to it later on.
Yeah, that's true. That's true.
So would it, if we used potentially something that wasn't the MAC address, just some sort of UUID or something for the for each one of these, for each sensor, like would that, like is the MAC address just an arbitrary number that we're using that happens to be unique?
Arbitrary. Yeah.
Yeah. So I wonder if we do, because then you wouldn't even need. Well, I guess but that's the thing, is like what I'm trying to think through is, how does the sensor, when you send an MQTT command out, how does it know what sensor to go to? Because the sensor needs to have something that matches the database.
Well, so all I'm suggesting is that when you install a sensor in a Walmart or in your house in Puerto Rico or in the Red Sismica offices, what's happening is you already know that MAC address, because it's been given to you with the sensor.
Okay. All right, so we can't really, but we still need to stick with MAC addresses in some way, shape, and form, because that is what basically links. That's how MQTT understands what sensor to send commands and topics to.
Or what we could do is we could create a sort of, we could create the whole string with the site, with the network and everything else. It would just mean that before we handed the sensor over, we already on the database had established that MAC address equals something else, and then we can print out that alternative naming system on the box. So when that person calls up, Grillo, whoever it is, and says, "Hey, sensors down" or whatever, we know what MAC address that they're really talking to.
Okay.
It just means a bit of work before, but it's not. I mean, it's really easy to automate that.
I think that. If we are, or when we are shipping sensors to someone who is going to deploy them, I think it's more practical to leave assigning the station and network code on those people who are deploying the stations. As Elizabeth was saying, if you want to have collocated OpenEEW sensor with some other existing station, which you may not know in advance, so then you would be assigning these things after you deploy the station or after you establish a new station. So I think that assigning network and station codes, I think it should be, it would make more sense to me if it was done by those who are deploying those stations rather than us in advance.
Yeah, and I would say I agree completely with that. Because usually what happens in the field, you go out, you put out a station, and you usually use like a Palm or a iPad to set up that station. And with the digitizer and the firmware, and you put in, say, here is my station network name, my station name, and channel names.
Mm-hmm.
And you do that at every site when you're doing a deployment. One thing to think about is with the network codes is, I'm not sure if in Puerto Rico we're going to be using PR, because that would say that's part of the PRSN, Puerto Rico Strong Motion program, or if as a group if you guys wanted to have a network code for your global dashboard, because that would make it very distinct. Is here are these specific instruments and this global network.
How do Raspberry Shake do it, Elizabeth?
I'm fairly certain that I think Raspberry Shake have distinct network code.
I think so too. Yeah.
Yeah.
Okay. We should. How do we apply? We write to Iris? Or who do we write to?
Code. It's the FDSN who are in charge of that.
Oh, right. You mentioned that already. Okay. Okay. That network.
Can Václav or Elizabeth, can you send or just post in the dashboard Slack some examples of how sensors are named?
Yeah, for sure. Yeah.
Yeah. I think the naming depends on who's doing the naming. The network, beyond the network code, the actual the site name can be descriptive. It can be almost a joke depending on the seismologist out in the field.
Sure.
But things like channel names and network names are sacrosanct.
Okay. Channel name, network name.
So
And
Ryan-
which channel do you want me to put that in?
Oh, dashboard. Well, actually, it probably fits seismology a little bit more. So yeah, you can post it in seismology.
All right, I'll put them in both in seismology.
Yeah, that's awesome.
And Ryan, do you feel this is something that could be handled via the dashboard, this sort of naming system?
Yeah, I think so. I mean, we could even get a little more, instead of it just being one input, I mean, there's different ways that we can make it a little bit more user-friendly too, if we kind of get into exactly, if we kind of wrap our heads around these naming conventions and figure out okay, how could a website basically make it easier to enter these things, or easier, we could potentially really make it a nice sort of user experience. But at very least, we can just have an input and allow people to add whatever name they want to it.
Okay.
Yeah, I mean, that's definitely, I just, connecting it, having a form just take in a name and then having that post to the database as far as an input for a sensor or as a property on a sensor is not hard at all. It's just that making it actually useful in the end, which is to say that it connects to a MAC address and it combines all these other ways that you potentially can identify a sensor might take a little more work.
Got it.
Yeah, another reason why I think that we need to have these sort of standard naming of stations is that if we, that's something that I want to show now, if we want to have a C-Link or a C-Link ring server to pass the data on, for example, to existing systems like SizeComp, Earthworm, and stuff, those many seed messages that are going to be going through that C-Link server, they carry this information about the network and station code. So the MAC address would not fit that format. So that's something that we need to have there.
Okay.
Just before you go to that diagram, I just wanted to say to Elizabeth that I was speaking to some professors at the University of the Virgin Islands in the USVI, and they I wonder if it's okay if I could give them your email. They were curious about speaking with you guys.
Absolutely, because we actually are their network.
Okay, good. I think they mentioned that. So I got in touch with them, and they are going to. I'm just going to send them 2 sensors, just so they can get some. They don't have any seismologists, which is why they would need to talk to you guys. But they were interested in starting to put some around the islands. So that's okay if I pass your email on?
Yeah, and you could actually CC Victor as well, and Alberto. So all 3 of us are in the same loop as the investigation group.
Got it. Right, I'll do that. Sorry, Václav, that's it.
Yeah, no worries. Yeah, let me just show real quick. I think I was thinking a bit about now when we had this discussion about C-Link and other things. I was thinking a little bit how to because we had this inquiries from Puerto Rico and also other places, how to pass on the data that we collect. What would be the best or the easiest way to connecting to the data streams? So I thought about it a little bit, and also about the data archiving. So I put this together this is actually now running on AWS. So what I'm doing here is that I am subscribing to the MQTT where our data is streaming, and also actually now where I'm also taking in the Mexico data from the Grio network in there. And then I am running a C-Link server, which I'm right now using also for archiving the data. But this would be probably and easiest point for you as Elizabeth and anyone else who is interested in the data or integration of the data in an existing system like Earthworm, where to tap in, because well, this is I just tested this out yesterday, so we still would need to do a little bit more work to establish this like a solid system. But I think that actually this would be an easy point to connect and link the data to your existing systems. And it's also probably because this works quite fine and we are archiving the data in the S3 bucket. I think that I will use this for the seismology scripts that are running on Kubernetes now to tap in and take it over by the seismology scripts. So yeah.
Great. And you've got it running, right? So the ingestion module is receiving now the data?
Yeah. It's receiving the data. It also can take data from public seedling servers. I'm subscribed to some data from Iris right now just to test it out. But yeah, it's getting all the data, saving some temporary mini seeds that are taken over by the seedling server and sent out to different locations.
And Elizabeth, would this work? Would this be an easier way for you to access the data as well?
It might be. As long as I can get it into like a mini seed format, that makes it a lot easier for processing, because then I'll be looking at apples and apples versus apples and oranges.
Exactly. That's what I had in mind when I was doing this, because for you, I think that the plan was before to set up your own MQTT server, getting JSON messages, and then you have to convert, and that will be quite complex on your side. But this is just a standard mini seed chunks, 1 second chunks, or 512 kilobyte chunks. So this should be quite easy for you to subscribe to that.
Yeah, and that would also make it long-term easier to integrate into things like Earthworm.
Yeah, exactly. Yeah.
Perfect. Good. Yeah. I know, because that's going to be great, that stuff, because I know that we have the guys in Chile also asking about that as well for the sensors that they're using. So I think that's going to make this a little bit more friendlier for seismology. And so while we're at it, Vasta, was there anything else that's missing in that diagram that you showed that we need to still do? It sort of sounds like you built a prototype. Is there anything there that they're missing?
No, not really in the diagram. I need to adjust the seismology scripts to subscribe to this data to the seedling server. So that's some work on my side. So I need to work on that, and then maybe change a little bit of databasing of the stuff. But otherwise, I don't think that there would be anything.
Elizabeth, sorry, I've written it down somewhere. But you had mentioned how you wanted the station XML to be done. Can you remind us again what was the format?
Actually, I put the format in the Slack seismology chat as one of the links just now.
Okay, I'm sorry.
Yeah, because it was requested, and that way it'll give an idea for what the full metadata is. Because the station XML basically has all the information down, so you can even include things like telemetry and MAC addresses and all that information in a single XML.
And typically these XMLs are stored on your Earthworm database, I'm assuming.
They are stored, or you can convert them into something called dataless. But station XML is the modern metadata we have for every station.
And you would input that manually when you have a new sensor on your network?
And our network, well, we use a part of ANSS. So Puerto Rico is a bit different. So we have access to something called the SIS system, where we would put that manually into a system, and then it goes into a database. But if you have a standard network, like we are now having in Puerto Rico, you can say, here's the instrument, here's the digitizer, and just put in the serial numbers and create all the other information automatically. But that's something unique because we're using the SIS system.
Okay. That's why I look at that. But we could put it in manually then.
Yeah, you can put it in manually.
Okay. So as long as we stick to this convention, which you shared, then we could put it you could, or we could, or however, put it into your Earthworm.
Yeah, as long as it's a station XML, and you can even write a Python code to get the information from the database and write the XML. And
got it. Could you share a sample XML? I don't know if you've seen one, but I'm not sure I know what they look like.
Yeah, there's plenty sample XMLs on the ABS side. Yeah.
Okay, sorry.
Yeah.
Yeah, I was looking at one. The third link, I think Elizabeth sent, has a sample XML file for station XML.
Yes, I think that is like, yeah, that's the FDSL one. Yeah.
Oh, there we go.
Yeah. And this is seed metadata. So this is different than mini seed, right? They're just, mini seed is just like a truncated version of this.
Mini seed is the waveform data.
Oh, okay. So it's
it doesn't have any of the station data. That's why you usually say a seed file has the metadata and the waveform data.
Ah, okay.
So a mini seed file would have the waveform data plus some identifier, right? So you can connect it with the
that's it. Yeah.
Okay. Got it. Okay. Was there anything else to discuss? That seems pretty good.
I was just going to say about the dashboard. I mean, so I met with Kristen over the weekend, or I can't remember if it was last weekend or the weekend before then, but met with Kristen. We worked out some of the stuff on the events page to get, so if there is an event that to show, the stations that have picked up an individual event. So we're, in the process of building that. And then they highly requested ability to, have the map and the sensors page reflect, or the sensors table rather, reflect what you're hovering over, so you know what you're looking at in the map. Johnny has pretty much completed, and I think it looks really good. It's up on the dashboard. He hasn't opened a PR for it yet, but it's up on the dashboard Slack, and he has a little video of it. I think it looks good. So
Johnny.
The idea is, as I was saying, I think he's on vacation, which means that he's just programming all day long. So the idea that Kristen and I had, or that Kristen had, but that I think we're going to go towards, is on the sensors page, you only see sensors associated with your account, because now all the other network sensors are going to be on the events page. So the events page isn't really an events page anymore. It's just sort of like a big map of the whole event network overview, right? Events and sensors included. But then if you want to specifically manage your sensors tied to your account, then you would go to the sensors page. So it just sort of declutters it a little bit, was the thinking.
Perfect. What's so funny? I saw that video. I didn't know what I was looking at, and now I understand. So when they hover over it, it selects from the list. I get it.
Selects from the list, and it goes in the other direction too. So if you hover over the, he's showing that it selects it from the list from the table, but then if you hover over the table, it also makes the little circle wider, so you know what you're looking at.
Oh, that is awesome.
Yeah, I don't know, that code that makes up that sensors page is needed to be refined a bit. So the fact that he was able to do this and have it look really good, and it looks like works well, is quite impressive, because that code needed a little bit of refining, I would say.
Yeah, okay, Johnny.
So yeah, well, we will have whatever the next version of the dashboard is, hopefully fairly soon.
Excellent. Okay.
Sounds good.
So, I'm going to start looking a little bit at some of these firmware issues, and specifically, I'm also going to be looking at how we can start to store this connectivity history. Where do you need this connectivity history? You need it in the Cloudant database, right, for the dashboard?
Not necessarily. We can always connect to a different database that contains that. It depends on if it's easily added to those clouded records or if it needs to be kind of its own separate thing. I mean, how much data are we talking about here? Is it just sort of individual lines of when it disconnected, like those last will and testament lines?
Yeah, exactly.
Yeah, I almost think that, I mean, I would, if we could set it up for the future, I would say off the top of my head that we probably want to go beyond that in the future. So we probably want some database that's going to be able to handle sort of log events in general, and then output those into the dashboard, because it seems to me reasonable that the dashboard will eventually have a whole sort of like debugging system in it for sensors. So like you click on a sensor and you get the logs for the sensor, the connectivity history, all that kind of stuff, because that would make managing it, I think, useful. So I don't know if the cloud database is quite right for that. Maybe some sort of relational database or something like that can handle.
So let me see what we're doing in AWS, because what we do there is we are logging connectivity in Postgres from the sensors. So let me just see how we're grabbing that last will testament data and what sort of table schema we're using for the connectivity data. Let me have a look.
Yeah, because it could just be a data source that's just sort of devoted to like event logging and what happens with the sensors. But to start off, it can just have the last will and testament stuff in it, which won't be that much data. But then we have somewhere where we can expand it later on.
Yeah.
What I will be doing probably now for just QCing the data from stations, just some overall statistics that is going to be generated from the miniseed files, from the archive data. So, and from that, like we can also like gain quite a bit of useful information on like when the messages were sent, how much of the data, especially for those stations that are in continuous mode. So I can also pass this information eventually to some kind of a database.
Well, one thing that would be really useful, because you've got this huge test rig now, would be to try and test different scenarios. Like what would be really good is if you can imagine like a couple of scenarios. One of them is that you turn the router off for different intervals of time. So you turn the router off for 1 second, 10 seconds, 1 minute, 1 hour, and you just see to what extent these devices are able to connect again after that time period. Maybe also, I don't know if you're some way of like moving them away, so you have like poor connectivity, and then just see what, all of those things are really useful. Yeah,
I can do. Other people working from home will kill me probably if I disconnect the router. Yeah, I'll do it.
Yeah, I think that'd be really, really useful data, because we don't know what's going on in Puerto Rico, but we can't have that. I'm pretty sure with Ethernet it might be okay, unless it's an MQTT Watson problem, in which case that will be resolved. But when we move, but we need to work it out.
Yeah.
I don't think that issue is unique to Puerto Rico, because if you look at us that have devices that are not in Puerto Rico, our lights turn yellow as well. Like I just had to unplug and plug my router when you brought up the connectivity issues, and I didn't notice that for a couple of weeks. That was plugged in and there was a steady blue light because I had it covered. But there should have been no reason for it to go from green to yellow, because nothing's happened. I just kept it in the same place.
Yeah, and that's the other thing that needs to change. And the dashboard is only basing that yellow on just a one-time stamp in the cloud and database that only really gets updated, as far as I know, when you restart the sensor. So it really is not an indication of whether it is live or not. And so that needs to change. I think if we have a connectivity history or connection history, then we can base it more on actual information rather than just like when that little property in the database was updated.
Yeah, last will and testament is much better than that. So just having that message at the beginning is going to give us bad data, because you need to. Last will and testament is the MQTT system itself saying this device is disconnected at this time.
Yeah. So we definitely need to.
What I'm also going to do in parallel then is go through the firmware again, because I already did that when I was playing around with UDP, and I'm aware that there are some conditions with especially Wi-Fi connectivity, which I think could be an issue. So where possible, we really do prefer Ethernet. But yeah, Adrian, is yours connected by Wi-Fi?
Yeah, it's on Wi-Fi. So I guess comment on that is, I think it should be easier to know by looking at the device that there's something wrong. Because that steady blue light, I like had to remember that that's a bad thing because it normally blinks blue. That's why I have it covered.
Yeah, that's a very good point. I also think that once it's just on and not sending data, like it doesn't need to be such a bright blue light. I think maybe changing the colors a little bit would.
The steady blue gets me as well. The steady blue should be green, for example. So that's a pretty straightforward firmware change. Okay. Well, I think is there anything else? Quite a good list here.
Yeah, on Friday, I'll talk with Kristen to see how we can possibly integrate, the manually adding of sensors and also the connection history. Get some ideas for that.
Perfect. Yeah, I think that would be a big addition.
Yeah.
Well, thanks for joining us, Elizabeth. That's great that you came today. Thank you.
Yeah, my calendar actually finally has it in, so I should be here from here on out.
Excellent. I think it's your input here is really valuable. So appreciate it.
Yeah, and if you think of any idea that would make your life easier that the dashboard could provide, don't be shy about adding it to the dashboard in Slack, because we need ideas from the people that use this thing.
Will do. And if you have any questions about seismology, feel free to ask as well.
Yeah, that sounds good.
Great. So you have Slack open most of the time, Elizabeth, if we were to ping you on Slack?
It should alarm if you ping me. But I have it somewhat quiet.
Okay, we'll try.
Yeah.
Okay, folks. Well, if there's nothing else.
Yeah.
Okay. Well, thanks very much, everybody.
Thank you.
See you at the next one.
Yep.
Thank you. Have a good
Have a good
evening.
day. Bye.